Welcome, Knights, to the second lesson in Unit 7, Writing and Evaluating Algebraic Expressions. So you may have noticed right off the bat in the title of our lesson today is hidden in there that word that Mr. Hopper was telling us about, algebra. Algebra is this whole discipline of mathematics. You're going to take an entire class on it in high school, and this is just our 6th grade introduction to what is algebra and what are the things that we use to do it well. Before we dive into writing and evaluating those algebraic expressions, I want us to reach back in our memories from our lesson on Friday to ask ourselves, what is a variable? So take a minute and think back in your mind, or flip back in your notes if you can't remember, what is a variable? And then go ahead and write it down in your notes in this space, whatever you remember or what you flip back to see. All right, when I was flipping back and I was thinking back to what we learned on Friday, I remembered that a variable tends to be a symbol of some kind that we use to represent something that is going to change. So it's usually used, I'm going to write used to represent a value that varies. And if we remember, varies also means changes. So if that's a more familiar word for you to use, you can go ahead and use changes instead. So variable is a symbol that is used to represent a value that varies or changes. So in our past experience, we've been using variables like the letter H, or the letter B, or the letter C. We've been choosing whatever variable would make sense for that equation. So let's keep that in mind as we move on to our first problem for the day. A school lunch costs $3. Determine how much money is collected for each situation and write the numerical expression for each. So if a school lunch costs $3, and 50 students are going to purchase a school lunch, I know that I need to take that $3 and I need to multiply it by those 50 students that are going to purchase lunch. That is my numerical expression that it asked me to write. Now I need to make sure that I determine how much money is collected. So let's look at that next part. If I multiply 3 times 50, my answer should be $150. Let's take a look at the next one. 123 students purchase a school lunch. The price of the school lunch is not changing, so I'm going to keep my $3 exactly the same. But this time I'm going to multiply it by my 123 students that are purchasing a school lunch. I don't know how to multiply 123 times 3 in my head, so I'm going to go ahead and do that long multiplication off to the side, and you can go ahead and do the same. I did that long multiplication out to the side, and I was left with the answer of $369 if 123 students purchase a school lunch. So this is all things we're familiar with. This should be good review from Friday. Let's take it to that next level and write an algebraic expression that is going to represent the total amount of money collected. We don't get to choose a variable in this situation. It says let n represent the number of school lunches purchased. So to remind myself what that n is going to represent, I'm going to write over here n equals number of lunches. Wow. lunches purchased. Once I know that I have my variable locked in, I've written down what it's going to be, I can go ahead and write that algebraic expression. Because I noticed that this number was the one that was changing, this number is the one that was representing the number of school lunches, we are going to replace that changing variable, that varying number, the thing that's changing, with that letter N. So my $3 is going to remain exactly the same. But instead of multiplying by a specific number, we're going to go ahead and just use N instead. And if we remember from yesterday, that is a perfectly acceptable way to write it. But an even better way to write it would be like this. We take our 3 and then we write our N right next to it like that. 3N. This next part, section 3, this is our new piece for the day. So keeping in mind all this work that we've done up here, let's go ahead and take a look at number 3. How could we use that algebraic expression that we just created right here to figure out the total amount of money that would be collected if 300 students purchased a school lunch? 300 students purchased a school lunch. So we already have this algebraic expression right here. We have our 3N. And now we want to know if 300 students are purchasing a school lunch, how could we use this expression that we've already created to figure out how much money is going to be collected? I need to put that 300 students somewhere into this equation. So I want you to take a second and think, where would this 300 students fit into this equation, these 300 lunches that have been purchased? I'm recognizing that these 300 lunches purchased is actually just another value that I could substitute for my N, which is number of lunches purchased. So I can transform this equation that we wrote, this expression, into 3 times 300 lunches purchased. I'm going to replace my N right here with this 300. Once I've replaced that number, I can go ahead and solve. 3 times 300 gives me 900 total dollars collected if 300 students purchased a school lunch. So this is something new that we've just done, and I want to highlight it one more time. We had our algebraic expression right here, and our variable N was representing the number of lunches purchased. We were able to replace that N with 300 in this scenario because 300 students purchased a school lunch. Once we replaced that N with a value, we were able to determine that $900 would be what was collected. Let's go ahead and look at key point number 1. Go ahead and take a second and read that to yourself in your mind. How we pronounce this phrase here is an algebraic expression. An algebraic expression. With that in mind, go ahead and read key point number 1 to yourself. Key point number 1. An algebraic expression is created to represent a value that changes. So just like our variable, a value that changes or varies. Once it has been created, the algebraic expression can be used to solve for multiple values of the variable. So if we think back to what we just created up here, we could have put infinitely many values where that N was. Our scenario told us to put 300 there, but once we've created that expression of 3N, We could really put any value in place for that n that makes sense to solve for that solution. Let's keep this in mind as we move on to number 4. The cost to rent a skating rink is $300 for a party. The cost will be shared equally among the people who attend the party. Determine how much each person will pay if 25 people attend, 60 people attend. So we have $300 being spent for this party. And the people who are attending the party want to share that cost equally. If I'm sharing a cost equally, I'm going to split that cost up. So let's think, what operation do we use when we're splitting a cost up? When we split a cost up, we use division. So we're going to take our $300 and we're going to divide it amongst the amount of people who are going to attend this party. So in the scenario A, there are 25 people attending the party. I can use the expression 300 divided by 25 to figure out how much each person will pay. If you don't know 300 divided by 25 just off the top of your head, you can go ahead and set yourself up some long division over here and solve that problem out. I'm going to give you a minute to do that. Hopefully, when you took 300 and you divided it by 25, you ended up with $12 for each person to pay. Let's look at this scenario if 60 people attended. Our 300 is going to stay the same. We're still dividing because we're splitting that cost up equally, but now there are 60 people. So we need to take our 300 here and divide it by 60. Go ahead and take a moment to figure that out on your own. Hopefully when you solve that out, you got the solution of $5 for each person to pay. So let's move this into the realm of algebra and let's write an algebraic expression that can represent how much each person will pay to attend the skate party. It's giving us a variable here. We need to use P to represent the number of people attending. That makes sense. P is going to represent people. So we need to look back at the equations we've already done, and we need to ask ourselves what value is varying, what value is changing, what value represents the people. As I look back, my $300 remains the same, and it's not representing the people, so that doesn't make sense to put P in the place of 300. But I do see that this number has changed between these two options, and that the 25 and the 60 are both representing people that are attending. So I can go ahead and replace that 25 and that 60 with my variable of P. My algebraic expression for this scenario is 300 divided by P. Just a quick reminder, you can also write it this way, 300 divided by P, or this way as well, 300 divided by P. There are a lot of ways to represent division. Now we're going to use this algebraic expression that we created above to solve for some new scenarios. Our algebraic expression is this thing that we just created right here using our variable. We're going to use that to solve for 30 people. So we have our 300 divided by P. And now we need to replace our P. Our P represents people. So we need to replace our P with the amount of people that we have. When we replace that, our new expression becomes 300 divided by 30. I hope that you're able to do this in your head. If you're not, use some long division. Reason out 300 divided by 30. When we take 300 and we divide it by 30, we should end up with the value of 10. Those people are spending $10 a piece if 30 of them come to the party. We have our last one, 20 people. You can use that same expression. Once we create an algebraic expression, we can use it for any of these scenarios, for any number of people. So go ahead and transform that expression by putting that 20 in the place of our variable p. And I'll give you a second to solve how much money would each person need to pay if 20 people went to the party. If you're feeling stuck, I'm going to be solving it right here. By now you should have solved that. If 20 people came to the party, they would pay $15 each if they were splitting that cost evenly. We should have used this exact same algebraic expression every single time. This should not change unless our scenario changes. Our P is representing our people. If we ever forget what our variable is representing, we usually write it right up here in this corner so that we can remind ourselves what it's representing. This concludes our guided section. There are a few check for understandings down here. I'm going to help you annotate that first one together so that we can determine a perfect variable to use. Then you are going to solve these on your own. We're going to go over them in class. Go ahead and just do number 7, 8, and 9 and stop where it says stop here at that stop sign. You're going to stop right there. There's some more things in your notes below that, but you're going to wait for class on Monday to go over those all together. So let's take a look at the first one. We'll read the first one together. Karen wants to eat 4 chicken nuggets and some Takis for lunch. Write an expression that will represent the total number of things that Karen will eat for lunch. I already know that Karen wants to eat 4 chicken nuggets. I see that word and we know in math class when we see and, that is representing addition. It says, and some Takis for lunch. Some Takis. It's not very specific at the number. So I think that is going to be the thing that may change. So I need to choose a variable that I'm going to use to represent Takis. Whatever variable I choose, I need to make sure I write it down in the corner. I'm going to pick a capital T to equal Takis. Once you pick your variable, you should be able to write an expression that represents the total number of things that Karen will eat for lunch. Once you've solved number 7, go ahead and also solve number 8 and number 9 all the way down to the bottom where you see it say stop here, and that's where you're going to stop. Just try your best, and we're going to be going over it in class on Monday. See you then.